Our world is facing massive environmental challenges. That's something we all know. Every year, we observe our biodiversity diminishing. We see how our CO2 sinks decrease. But something you might not know is that one of the major contributors to that is the rubber tree. The way we cultivate rubber from the para tree Hevea brasiliensis has led to significant environmental and economic impact. Since 1993, more than 4 million hectares of rainforests have been destroyed. That's an area 2,400 times larger than Paris. But natural rubber is very important for us. We require over 15 million tons of natural rubber every year. That would compare to 3 million elephants. And we need it for over 50,000 products, like tires, shoes, medical products. But we only rely on one plant species for that, which is the para tree. And this comes with many problems. The trees are highly vulnerable to diseases, and issues like labor exploitation and abuse persist in the industry. And that's why we saw the need to diversify our natural rubber supply for a more sustainable future. With only one plant adaptable to our local climates, we have singled out Taraxacum coxsagis, a rubber-producing dandelion species, as a promising candidate. So the dandelion is able to produce its rubber within its roots. It can be grown on low nutrient soil, so it does not necessarily have to compete with the food production, and it can be grown in our latitudes. So to find that out where it can actually grow, we conducted some geospatial analysis where we looked at the climatic conditions of where the dandelion is already growing and of field trials. So then we were able to map out the potential growing areas of Taraxacum coxsagis and compare it to the rubber tree, not only in present, but also for the future, taking into consideration climatic changes. Now, you might also be wondering, if the dandelion is so promising, why is it not being cultivated on a large scale yet? And we asked the same question when we started our project. So we contacted an expert, the dandelion breeder Dr. Eickmeyer, who revealed to us that the main bottleneck lies within agricultural traits such as seed size, root architecture, and leaf morphology. As a result, we shifted our focus from increasing the rubber yield to investigating the key features that it takes to support mechanized harvesting and sowing. Now that we know what the goal is, we want to take you step by step on the journey that it takes from a wild-type plant to a well-adapted industrial crop. At first, we started testing fast and efficient transient testing methods like leaf infiltration and protoplast isolation. Now, to benchmark our leaf infiltration, we used the Ruby reporter system. There we saw successful genetic expression through the accumulation of betalain pigments. With our protoplast transformation, we were able to successfully isolate and transform protoplasts, and we saw successful GFP expression. This then again highlighted that our protoplast approach was a reliable high-throughput method to then test our part collection. In the second step, we wanted to get to know what it actually takes to genetically engineer the dandelion. So again, we consulted an expert, which is Professor Prüfer. Professor Prüfer is from Münster, so some of you might know him. And he highlighted to us that just basic genetic tools are missing for the dandelion. So we decided to build exactly those, to build these genetic tools for the dandelion.
So, when you want to build a toolbox, you also need to consider where your tools shall come from. And this is what we did. We took into account the upcoming EU regulations, because as you might be aware, to get a genetically modified plant out into the agricultural environment in Germany is impossible. Therefore, the upcoming EU regulations prove to be a promising future, because they try to change these approaches. For that reason, we reached out to the NGO EcoProc to get a better understanding of the legal situation. And what they explained to us is that the upcoming regulations will split the genetically modified plants into two distinctive categories, NGT1 and NGT2. For this presentation, we will be focusing on NGT1 as this is the more interesting one. NGT1 organisms will not be related to the common genetically modified plants, but will instead be categorized as another normally bred plant would as well. But what is needed for that is cisgenic or endogenous parts. And we took that to heart, so our crops can be later be on the field. This is why we built our own transcriptomic pipeline to identify only endogenous parts from dandelion to be able to characterize them. Now, after we got 40 different parts that we could use, we decided on characterizing them using a ratiometric approach. Therefore, we have our reporter construct here with a normalization cassette, which will always stay the same, and a measurement cassette. There, our regulatory elements will be switched out accordingly with what we are currently measuring. This allows us to be independent of transformation efficiency or other things that will be going on in the plant. With these methods at hand, now we were able to actually characterize our parts. Here we'll be focusing on the 3' UTRs we have characterized. And as you can see, we see various expression strength for our 3' UTRs in Taraxacum officinale, which is the dandelion you will find out when you just step outside and look. And also the same is true for Taraxacum coxsagis, which is our rubber-producing dandelion species. Now, these results are very promising to us and very exciting for us, but might not be that exciting for you if you're not working with dandelion. This is why we also made sure to test these parts in Nicotiana bentamiana, a well-established model plant, so you can use this as well if you want next year and pick and choose which part you want to use. As I have mentioned, we wanted our parts to be as broadly applicable as possible. Therefore, it is important, if we want to use it in the field later on, that stable transformation and stable expression of our parts is actually possible. However, stable plant transformation is usually outside of the scope of a typical iGEM team, since stable transformation of plants takes a really long time. This is why we have adopted the cut-the-budding protocol, which allows us to regenerate transformed material, stably transformed material even, in only a matter of 2 weeks. Thereby, you get a fully grown dandelion plant, just cut off the roots, dip in an agrobacterium solution from both sides, and then you just wait for 2 weeks, and transgenic root and shoot material will grow from that. And we did this. We first validated this approach, again using the Ruby reporter that Bielefeld might be familiar with. And secondly, we then tested our own parts, for example here, the promoter 5' UTR from tubulin, which you can see successful EGFP expression in our approach. With these methods at hand now, we are able to go into the future for a well-adapted industrial crop, in being able to alter seed size, root architecture, and leaf morphology. Now, where we have been talking about the future,
it was also very important for us to talk about the past. So when we started researching for our project, we also saw that, or we found documents that revealed that also the National Socialists in Germany in the 1930s and 1940s also did their research or conducted experiments for dandelion as a natural rubber resource. And this, first of all, shocked us. We had many discussions in our team if we should continue with our project or not. So we now want to share with you what we have done, what we have learned, and in case you ever stumble upon such a situation. So again here, we first conducted an expert, a historian, Dr. Susanne Heim, who also worked in this field, did her research on this. And one quote that stuck with us the most during this time was the following: "It is very important to be aware of where the knowledge you're building your research on comes from and under which conditions it was gained." So she highlighted that the past happened, but it is important that you have to be aware of it. And this is exactly what we did. We took a look into the history and went to the Wollheim Memorial in Frankfurt, and we met with the curator Gottfried Kössler, who told us about the situation of the forced laborers from these rubber factories. And something he highlighted was that it is important to keep the memory and to share the knowledge about this. And this is what we also did when we had our exhibition at the Botanical Garden in Marburg. So there we had the chance to not only showcase our projects but also show the historical part of this. So here you see a bit of it. We had 3 booths. We really got to do an exhibition there. We got to meet some of the 8,000 visitors over the course of 2 days, and we were able to share what we have learned and what had happened.
Now, coming back to the present, we want you to maybe continue our work, build your own work upon us. But we also don't want you to fall in the same pitfalls as we have. Therefore, everything we have learned this year, our refined protocols, our results, how we challenged our history, we packed everything together in one Dandelion handbook that you can find on our wiki. And so you can use and build your own research on top of it. Which brings us to our core achievements of this year. We have built and characterized 31 distinctive endogenous dandelion parts for Taraxacum coxsacus and 37 parts even for Nicotiana bentamiana. We have engaged with over 27 stakeholders from 7 different sectors, created the aforementioned Dandelion Handbook, and have refined 4 different plant transformation protocols, 2 transient, 2 stable protocols, for the dandelion transformation. And, as a small fun fact, just during this presentation, the weight equivalent of 80 elephants has been produced in natural rubber. I would also like to use this opportunity to thank our sponsors for their ongoing support, as well as everyone else that has supported us during the years. I would also like to thank you, everyone, for coming and listening to our talk and to this project, which is really dear to our heart. Thank you.
Woo! Well done. Thank you guys so much.